Welcome! In this video, we will explore how clear and precise interface specifications help ensure that all relevant stakeholders have access to accurate, up-to-date and traceable information. So what exactly is an interface? In short, it is the point of interaction between two systems, where they exchange information, energy or materials. For instance, imagine an adaptive driver assistance system, commonly known as ADAS. This system includes physical interfaces, such as a speed sensor detecting road velocity, as well as functional interfaces, like a signal that sets the target speed. Having precise, up-to-date interfaces is important because they ensure that the pieces of your system fit together. And most problems in product development happen during integration. There are countless examples, but let me share one with you that went through the press in the early 2010s. Back then, GM planned to launch its semi-autonomous driving feature on the Cadillac CT6, combining adaptive cruise control and lane centering. But things didn't go as planned. Complex interactions between sensors, control systems, and driver monitoring tech created serious hurdles. These integration problems led to multi-year delays. GM missed their original launch window, lost ground to competitors, and had to defer revenue until everything could be ironed out. And this wasn't just a technical failure. The root causes involved coordination, timing, and misalignment between teams. But technology can help solve this. With clear, traceable interface specifications, teams stay aligned and integration stops being a guessing game. These issues extend beyond automotive. Rail, aerospace, medical, and many other industries face similar, often higher stakes integration challenges. Standards and maturity models like ASPICE reflect how engineering excellence improves quality and safety, which is why more organizations are adopting them to build trust in their development process. Model-based systems engineering in general, and SysML in particular, are great for ensuring that interfaces match. To demonstrate this, let's have a look at an IBM engineering Rhapsody model of an ADAS. We use Rhapsody to make all interfaces explicit from the very start by modeling them in our system context. While this diagram is simple enough to be understood by all stakeholders after a short introduction to SysML, this internal block diagram might already be too complicated to be accepted by some. SysML is powerful enough to capture the interfaces with a level of precision that can drastically reduce problems during integration. But what's hard for non-modelers to understand is that the diagram is just a view of the model, not the model itself. For instance, the proxy port P-speed sensor is typed with the SysML interface block, which in turn contains a flow property with its own type. This level of precision allows tools to verify compatibility of interfaces. But this only works if the provider of an interface makes all relevant information available, while the consumer has the means to use that information. So, how do teams work today? In many organizations, interface management is messy. Teams rely on scattered documents. Mature organizations use modeling tools like Rhapsody to define interfaces, but many stakeholders remain outside these tools due to access limits, lack of training, or collaboration constraints with external partners. This leads to delays, miscommunication, and finger-pointing. Stakeholders range widely, from developers and testers to safety engineers and suppliers. Not all need or want full model access. Instead, think of stakeholder maturity as a spectrum, from those who only view static PDFs to those working live in the model. The goal is to support everyone appropriately, without losing consistency or traceability. Power Pack from Sodius Willett provides a puzzle piece to ease the pain. Many elements provide an entry in the context menu for ports and interfaces that allow to trigger the generation of an ICD. This feature takes advantage of publishing for IBM Engineering Lifecycle Management. The script selects the right template for the current level of architecture and stores the resulting ICD in the model tree under controlled files. It generates a Word and PDF document. This document can be seen as a read-only view on the model, fit for stakeholders who feel more comfortable with documents. The templating mechanism from publishing allows us to customize the template in various ways. For more sophisticated use cases, the Power Pack from Sodius Willett allows tailoring that goes beyond publisher, as it has access to the full model. This feature generates HTML that provides interactivity. It does not require a server, so you can share it with internal and external stakeholders. They do not need a Rhapsody license. Further tailoring is possible. For example, we could include requirements or perform interface consistency checks as part of the ICT generation process in order to identify actually used interfaces. Distributing generated PDFs or HTML may not be the end goal, but it's a solid starting point for strategic interface management. A consistent, standardized interface description helps downstream teams confidently consume and implement interfaces. It reduces ambiguity and, over time, it sparks curiosity and adoption of modeling practices even among initially hesitant stakeholders. For example, the generated HTML can provide structured access internally, while the PDF can be used for contractors. Word documents can be used to track changes through redlining, enabling structured reviews and formal baselines. From here, organizations can take meaningful next steps. Align with global configuration management to ensure interfaces are versioned, traceable and baseline aligned. Use Power Pack to enrich ICDs with semantics, traceability and stakeholder-specific formatting. Support more output formats like JSON for automation or RecRF for cross-organizational sharing. Integrate with CI/CD pipelines for continuous validation and up-to-date docs. Use interfaces as a foundation for contract-based and behavioral-driven testing. Better interface management with generated ICDs provides fewer integration surprises, improved collaboration across silos, faster onboarding for new team members, reduced time spent on documentation, improved traceability and auditability, clearer expectations between suppliers and OEMs, easier compliance with industry standards like ISO 26262 or ASPICE, and increased confidence in reuse and modular development. In the end, the model is the single source of truth. The interface specification isn't a separate document. It's just one of many tailored views for specific stakeholders. When done right, interface specifications become a living part of your development process, not just paperwork. Want to learn more? Download our white paper for practical insights on strategic interface management and how to get started.